Welcome to Lionheart Academy. This is Richard Tai. We are continuing our trigonometry lesson. This is number 6. Today our topic is coterminal angles and reference angles. I believe we have talked about coterminal angles before, just a little bit, but today let's go ahead and focus on that. Okay. So first, let us start with a diagram of coordinate planes. Right now, most of our discussions, pretty much all of our discussions regarding angles is related to the coordinate plane. And that is something that's very important because we have to be able to have a coordinate plane, XY axis, second coordinate plane, in order for us to understand the angles and its behaviors. Alright, so what is a coterminal angle? Well, what are coterminal angles? I'm sorry. Coterminal angles are angles that share the same terminal side. The word coterminal, co means together, terminal means the terminal side. So coterminal angles means that they're the angles that share the same terminal side. So for example, let us go ahead and draw the initial side here. The initial side is always on the positive x-axis, and then we can rotate from the initial side. This will be our terminal side. Now notice our terminal side can be either in quadrant 1, quadrant 2, quadrant 3, or quadrant 4, or it could be one of the quadrant angles. So let's say it ends up in quadrant 3 today. Okay, this is quadrant 3. So the terminal side of the angle lies in quadrant 3, or the terminal side of the angle is in quadrant 3. This will determine the property of the angles. So it's very important for us to understand which quadrant the terminal side is in. So let's go ahead and write this as initial side, and this as the terminal side. I'm sorry. Terminal side. Okay. So this angle, how do I get to this angle? Well, I can the simplest way is go from the initial side and rotate in the positive direction. So let's call this theta. And the positive direction is the counterclockwise direction. So this is angle theta, rotating from the positive side counterclockwise to the terminal side. But I can also reach this angle through, I can also reach this terminal side by rotating clockwise. So let's call this angle alpha. So angle alpha and angle theta, they're not exactly the same angle. However, they share the same terminal side, and therefore they share a lot of the common properties. So we can consider them for a lot of our purposes to be the same angle. However, they are not the same angle, but they do share the same terminal side. And so later on, when we see in our calculations of sine, cosine, and tangent, they will have the same value because they have the same terminal side. But this too is not only coterminal angles that's possible. I could have done this. We could have gone from the positive side, rotating but passing that and complete one rotation and come back and then hit the terminal side here. Let's call this green angle beta. So green angle beta is also coterminal with angle theta and angle alpha. The three of them, they're all coterminal angles. In fact, I can have an unlimited number of coterminal angles because there are so many different ways I can rotate and stop at the same terminal side. I can rotate clockwise 3 times, 4 times, and stop at the terminal side. Or I can rotate clockwise 3 or 4 times and then stop at the terminal side. Okay, so either way you can rotate the positive direction or negative direction and stop at the terminal side. And so, but what is their common relationship? How do they all relate to each other? Well, if I look at beta, right, I rotated one extra rotation, then I stopped the same terminal side. So it's basically the same at theta, but I had one extra rotation. And if you remember, one extra rotation is 360 degrees more, or 2 pi radian more. So how do I find a coterminal angle? I simply add and subtract 360 degrees. Because every time I end up at the same terminal side, I have to go one more or one less revolution. Okay, so it's 360 degrees times n. And what does n represent? N would be simple numbers, 1, 2, 3, integers from 1 to 3, and 1, 2, 3, or 4 or 5. This means that I'm adding or subtracting a multiple of 360 degrees. So I'm adding or subtracting a multiple of 360 degrees. Or I'm adding or subtracting a multiple of 2 pi. Okay, so n can be 1, 2, and 3, so on and so forth. So this is how we can find our coterminal angles by adding or subtracting 360 degrees, or adding and subtracting 2 pi. But it's not just 360, it can be multiple of 360. So let's take a look at our example here. Let's say we have 145 degrees, and we want to find the coterminal angle for 145 degrees. So to find the coterminal angles, I simply can add 360 degrees. So if I add 360, I will end up with 400, actually, it's going to be 505 degrees. Okay, that would be the first one. And I can actually add twice of that. I can add 360 degrees times 2. I can add 145 plus 360 degrees times 2. So we can add 145 plus twice of 360 degrees, a multiple of 360 degrees, which will come out to be 865 degrees. Okay, so let's say we can also do the same thing on the negative side. We can do 145 and minus 360 degrees. If I do that, I will get 115 degrees, a negative 115 degrees angle. Okay, let me go ahead and make sure that you can see the negative sign right there. Negative 115. And I can minus 720 degrees also. Okay, so how do I find a positive or negative coterminal angle? These two are the positive coterminal. These two are positive coterminal angles of 145 degrees. And this one is negative coterminal angles of 145 degrees. So I can simply add and subtract 360 degrees or 2 pi to get a positive or to get a negative coterminal angles. Now let's go ahead and run another example. Let's say we have 14 pi over 3, okay, and we want to find a coterminal angle that's between 0 and 2 pi. So that means I don't just want to find any coterminal angle. I want to find a coterminal angle that's between 0 and 2 pi, or between 0 and 360 degrees. Okay, in the first 4 quadrant, in the first revolution. So first of all, I have to ask myself, is 14 pi over 3, is that greater than 2 pi? Let's think. 14 divided by 3. So 14 pi over 3, is that greater than 2 pi or less than 2 pi? Well, I think 14 divided by 3 is more than 2, right? So what we have to do, if it's more than 2 pi, then let's subtract 2 pi and see what happens. Now, when we subtract fractions, we have to make sure the fractions have the same denominator. So it will be 6 pi over 3, that's 2 pi. So it will be 8 pi over 3. Then let's ask ourselves, is 8 pi over 3 greater than 2 pi? I think it is. So let's take 8 pi over 3 and then minus 2 pi one more time. We have to subtract 2 pi to the point that is between 0 and 2 pi. Now, so this is going to be 8 pi divided by 3 minus 6 pi divided by 3. So then we got 2 pi divided by 3. And now I think that's less than 2 pi. So that would be the correct coterminal angle for 14 pi over 3 between 0 and 2 pi. Now 8 pi over 3 here is a coterminal angle, but it's not between 0 and 2 pi. Okay, so let's do one more example here. Example number 3. Let's do negative 12 pi over 5. Okay, so let's go ahead and find the coterminal angle that's between 0 and 2 pi. So let's take 12 pi over 5, and I know it's negative, so I'm going to add 2 pi to it. Alright, so negative 12 pi over 5, you plus 2 pi. Now we want to write 2 pi in terms of the denominator of 5, so it's going to be 10 pi over 5. You multiply the numerator and denominator by 5, you get 10 pi over 5. So you get negative 2 pi over 5. Now negative 2 pi over 5 is still less than 2 pi, it's still less than 0, actually. Less than 0, I'm sorry. So we have to add 2 pi one more time. Just add 2 pi one more time. Okay, so it's negative 2 pi divided by 5 plus another 10 pi over 5. So I get 8 pi over 5. Okay, and then that is the answer for this example. That is the answer that's the coterminal angle for negative 12 pi over 5 in between 0 and 2 pi. Alright, so let's go ahead and take a look at the next topic here. Our next topic will be about reference angles. So what are reference angles? Alright, now we're going to label reference angle as called theta prime. Okay, that little dash out there is called theta prime. So what is a reference angle? Now I'll give you a definition in a minute, but let's go ahead and take a look at the order plane again, the order pair again. Excuse me, the coordinate plane again. Okay, so we have the positive x-axis, always label it. Positive y-axis, always label like that. All right, the reference angle theta prime is the angle, the acute angle formed by the terminal side of theta with the closest x-axis. Closest x-axis. Okay? So what it means is, if we have an angle in any quadrant, now the quadrants is very important in this case, so let's go ahead and review the quadrant. We have quadrant 1, we have quadrant 2, we have quadrant 3, and we have quadrant 4. And as you can see, quadrant 1 is when x and y are both positive. Quadrant 2 is when x is negative, when y is positive. Quadrant 3 is when both y and x are negative. And when quadrant 4 is x is positive y, but y is negative. Alright, so this is basically, reference angle is basically a way to help us relate any angle back to an angle in first quadrant. Now, why do we want to do that? Why do we want to relate any angle? Why do we want to relate the angles back into first quadrant? Okay, sorry, I lost my place for a moment here. Why do we want to relate any angle back to first quadrant, theta? The reason is, if we deal with the angle in theta in first quadrant, it's easier to deal with because both the x value and the y value, or y coordinates, are positive for the terminal side. Okay, we'll deal with that a little bit later. So it's important to go ahead and get the angle into the first quadrant, is to relate it to the first quadrant. So in first quadrant, it is its own reference angle. If an angle is in first quadrant, it's own reference angle, because the closest x-axis is the positive x-axis, and that's the acute angle. So we're not going to measure from here to the negative x-axis. We're going to measure to the closest x-axis. So reference angle is always acute. It's always between 0 and 90 degrees. Okay? Lost my place. So let me put a 0 degree here, 90 degree here for reference, and this is 180 degrees. 270 degrees for reference. Okay, so if theta is in quadrant 1, so we're going to write the rules down, then theta prime will be equal to theta. So theta is its own reference angle. What happens if theta happens to be in quadrant 2? Let's say this terminal side is in quadrant 2. Well, the closest x-axis is the negative x-axis, which is 180 degrees. So this is the angle. This is the angle that's going to be called the reference angle. So how do we calculate that? So if theta is in quadrant 2, as you can see, theta prime is the difference between theta, the terminal side, and 180 degrees. So theta prime is 180 degrees minus theta. Another way to write this is theta prime would be equal to pi minus theta, because 180 degrees is pi. Now, if we're in quadrant 3, however, let's go ahead and draw a diagram for quadrant 3. Okay. If you see in quadrant 3, this would be the terminal side for angle theta. This angle would be theta prime. So if theta is in Q3, quadrant 3, then the reference angle is going to be equal to theta minus 180 degrees, because you see in this case theta is greater than 180, so that's their difference. And so theta prime would be equal to theta minus pi. So that's in quadrant 3. And then lastly, in quadrant 4, okay, so let's say the terminal side is in quadrant 4, that angle formed between the x-axis and the terminal side will be this angle. And so let me write it down here. If theta is in Q4, in quadrant 4, then theta prime would be equal to 360 degrees minus theta, because this final terminal side is not just 0 but also 360 degrees. So that's the difference between 360 and theta. So theta prime also can be 2 pi minus theta. Okay? So this is the rules for reference angle. So let's go and do a few examples, and then we'll see how it works. So let's say theta is equal to 123 degrees. So what would theta prime be? Well, first of all, 123 degrees is between 90 and 180, so that's in quadrant 2. So we're going to use the quadrant 2 rule. So it's going to be 180 degrees minus 123 degrees, which is going to be 57 degrees. So 57 degrees is the reference angle. What it means is 123 is related to 57. 123 degrees is related to 57 degrees. Okay, we'll go ahead and come back to that a little bit later. Let's say theta equal to 3 pi over 4. Alright, let me go ahead and do 13 pi over 4. Alright, so 13 pi over 4 is in which quadrant? That's a good question. Well, if I go ahead and think about this, 2 pi over 4 is 8, right? 2 pi over 4 is, 8 pi over 4 is 2 pi. So what it means is that it's greater than 2 pi. And so 13 divided by 4, if I do 13 divided by 4, it's actually greater than 3 pi, right? Because 3 times 4 is 12. So 13 divided by 4 is 3 with remainder of 1. So think about this. We started with 0, and then this is 1 pi, and this is 2 pi, this is 3 pi, and so it's 1 pi over 4 greater than 3 pi, so it should be somewhere between in quadrant 3. So in quadrant 3, the reference angle is angle minus pi. All right, so it would be 13 pi. Oh, however, one thing is 13 pi over 4 is not in third quadrant. It's not it's not between 0 and 360 degrees first. So what we have to do is take 13 pi over 4 and minus 2 pi first. Okay, so let's go ahead and do that. So it's 13 pi over 4 minus 8 pi over 4, and that will give us 5 pi over 4. So we're finding this is the coterminal angle. Here, what we learned about coterminal angle comes into play. This is the coterminal angle between 0 and 2 pi. Okay, so now we know which quadrant it would be. It's 5 pi over 4, so it's in quadrant 3. So then theta prime would be 5 pi over 4 minus pi. Okay, so that would be 5 pi over 4 minus 4 pi over 4, and that will give us pi over 4. So pi over 4 is the reference angle for 13 pi over 4. So if the angle is too large or too small, if it's greater than 2 pi or less than 0, we have to go ahead and bring the angle back to the first rotation, if you will. Find the coterminal angle between 0 and 2 pi first. Then before we can do the reference angle. All right. So this is the end of our lesson today. Okay, we hope you enjoyed it. Please leave any questions and comments in the comment section below. Please also continue to follow us for our next lesson. Thank you.